Hello everyone, this is Mr. Fawcett, and I'd like to welcome you back for another lesson in AP Calculus AB. Today we're going to start our discussion of trig functions and trig identities and how they can help us evaluate some limits. This topic is usually one that students tend to shy away from, and they don't like to put in a lot of work in this topic because it's not as fun. It can be difficult. It looks different than other problems because you've got these sine, cosine, tangents, cosecants, secants, cotangents, and we're just not as familiar with them because they don't pop up as much in algebra and geometry. So we're not as comfortable working with them, but we need to become comfortable because they're going to appear not only in your practice problems in an AP Calculus course, but also in numerous spots on the AP exam. And you don't want to limit yourself in what problems you can and can't solve because you didn't put forth the time and effort to really become proficient with working with these functions and identities and formulas. So this lesson may be multiple parts, as I know some of this can get tedious and we may need to go into quite a bit of review, but I just challenge you to stay focused and don't just try to do the bare minimum to get through these problems in this section of the chapter because they are going to pop up again, and it is quite a useful tool to have as you move forward, that being the knowledge and ability to work and manipulate problems that involve trig. So let's get started. We have two limits below. They do involve trig. And again, as soon as we see a limit expression, we're now at the point where our brain should automatically say direct substitution, right? That's what I need to attempt first. And then if we need to branch off down a different path, we can, but you want to always try substitution because not only will that be the easiest method if it works, but it also can tell you which direction you need to go next. So let me pull out my pen and we'll get going. So number one, we're just going to substitute in pi for theta and see what happens. Again, cosine of pi, if we think back to our unit circle that we should be pretty familiar with after probably using it quite a bit in pre-calculus, the cosine of pi is -1. So I get 2 times -1, but I am going to square it. So that's going to give me 2 times 1, which is going to give me 2. And we are done, right? We also know that the cosine function is continuous at pi. So we are allowed to just substitute and come up with a correct answer. Let's look at number 2. Again, we do have a rational function here, so there's a chance we may get an indeterminate form when we substitute in. We may get the limit of the denominator may be 0, which means we might need to look for a vertical asymptote. Or maybe we need to try to rationalize the numerator or the denominator if we get an indeterminate form. But again, that all starts with substitution at the beginning. Fortunately, it does not look like we are going to get an indeterminate form here. It looks like we just have to simplify. So I'm going to get sine of 2 pi in my numerator. If that's not clear, just note that these 3's will simplify together. These 3's will too in our denominator. So I get sine of 2 pi over 2 pi. Sine of 2 pi, again, think back to unit circle, it's going to be 0. And because our denominator is a real number other than 0, this will come out to be 0. Okay, remember, it's only when we get 0 in our denominator that we are going to look for a vertical asymptote. So again, these were two pretty straightforward problems. They were trig, but they were actually a little bit easier than some other limit expressions we've looked at. So just because you see trig, just because you see limits that have some trig stuff going on doesn't mean they're going to be super difficult. Now, there's certainly ones we're going to look at later that are more tedious, but we started off with these. Just goes to show you don't just shy away from these problems because you see some trig. Sometimes they will be pretty straightforward. So again, what I put down here, sometimes we will not be able to use direct substitution and we'll run into an indeterminate form. When this happens, we must know how to manipulate the expression so we can evaluate the limit. We will look at 3 different manipulation techniques in this lesson. The first thing I'm going to encourage you to do is pause the video and write down any trig relationships that you are aware of. So this could be very basic, such as what does sine mean? You could talk about what cosecant is, what secant is, and you could come up with some, maybe you remember the double angle formula, or maybe you remember the Pythagorean identity. So anything that you remember, any relationships, any formulas, any equations dealing with trig, go ahead and just write those down now, do some brainstorming. Then I'm going to focus on the most important ones that we'll need to carry forward with us. Okay, so hopefully you've had some time to do that. Again, I'm only going to focus on the ones that we're going to need to use moving forward. So the first one that we're going to look at is tangent. So tangent of theta, we should be able to rewrite this in terms of sine and cosine. So hopefully we are aware that tangent of theta is equal to sine of theta divided by cosine of theta. The next one, secant of theta. Okay, remember this is the reciprocal of cosine, so this is going to be 1 over cosine of theta. Likewise, for cosecant, CSC of theta, that is the reciprocal of sine of theta. Okay, so sometimes manipulating an expression or equation may be as simple as rewriting one trig function in terms of another. There are other times, though, where you may want to use something a little bit more complicated, and that is the Pythagorean identity. So sine squared of theta plus cosine squared of theta is equal to 1. And this is certainly something that you're going to use somewhat frequently throughout not only this unit and chapter, but throughout the course as a whole. This one is the most important trig relationship other than the ones we have here on the left. I mean, those are kind of the basic ones. I expect you to know those. But as far as equations, formulas, and identities go, this one is going to be the one that you use the most. And you know what? We forgot to do cotangent. So remember, cotangent is just the reciprocal of tangent. So that's just going to be cosine of theta over sine of theta. Should not forget that one. Okay, so these may be good to keep with you as you work through the problems in today's lesson until you become familiar enough with them where you don't have to keep looking back at a cheat sheet or whatnot, because you're not going to, of course, get these on the AP exam. So you want to know them. All right, let's get rid of these and let's look at this limit right here. So you may be ready to jump in and try to manipulate either the numerator or the denominator using one of our identities or formulas. But again, I know I'm kind of hammering this home, but there should be something we always start with when we're trying to evaluate a limit. Right? There's always a clear starting point and everything branches out from there, and that's substitution. So I'm going to substitute. We can kind of tell that my denominator is going to go to 0. Maybe you're able to tell that the numerator is also going to go to 0. So this isn't going to give us an answer, but it is going to tell us, whether we have an indeterminate form or whether we may have a vertical asymptote, etc. So if I look at my numerator, that is going to equal 1 minus cosine of 0, which not theta anymore, 0, which we know is equal to 1, so 1 minus 1 equals 0. My denominator sine squared of theta, which is going to be equal to sine squared of 0, which is 0 squared, which is 0. So we do get an indeterminate form here. I'm going to erase this because I am running out of space, but maybe you were able to squeeze it in there a little better than I was. So if we see an indeterminate form, remember we have some methods that we've learned so far, right? We can try to factor, we can try to rationalize either our numerator or denominator. Or today, we can try to use some trig manipulation. So that's what I'm going to have you try to start out with. Take a look at either your numerator or denominator and see if you can rewrite them in a way where you may be able to do some simplifying, right? So, see if you can get a sine of theta in the denominator and a sine of theta in the numerator, or a 1 minus cosine of theta in both the numerator and the denominator. Is there a way for us to manipulate that expression to where we can do some simplifying so that we won't have an indeterminate form when we go back and try to substitute? So pause the video, take a shot at that. Okay, once you've taken a shot, I am going to show you what I would attempt first. If we notice our denominator right here, that is part of the Pythagorean identity, right? So we have sine squared of theta plus cosine squared of theta is equal to 1. If I can isolate the sine squared of theta, well, then I could make a substitution, right? So sine squared of theta, if I subtract cosine squared from both sides, I get 1 minus cosine squared of theta. And I can take this right here and substitute it in for my sine squared of theta. And you'll notice that this looks somewhat similar to what we have in our numerator, right? So we may be able to do some more manipulation to simplify out some common factors. So I'm going to keep my limit. I'm going to have 1 minus cosine of theta in my numerator. And I'm going to have 1 minus cosine squared of theta in my denominator. Once you get to this step, again, the numerator and denominator look the same, but we can't just we can't just simplify out the numerator with the denominator, because one is just a cosine, one is a cosine squared. We also can't just simplify out these ones because they're not factors, they're part of a factor in both the numerator and denominator. But if we look at our denominator, that is actually the difference of squares, right? One is a perfect square, and cosine squared is a perfect square. So what we can do is we can have 1 minus cosine of theta in our numerator, and then I'm going to have 1 minus cosine of theta times the quantity 1 plus cosine of theta. And again, that's just factoring the difference of squares if we think back to Algebra 1. You may not have done something as complicated as this in Algebra 1, but it's the same idea, right? As long as you can identify that 1 and cosine squared are perfect squares, you can factor them. Now we have a chance to simplify, right? I have a common factor in my numerator and my denominator. So I'm going to be left with 1 in my numerator and 1 plus cosine of theta in my denominator. Now I can try direct substitution again. And if I substitute in 0 for my theta, I get 1 over 1 plus cosine of theta, of 0, which is equal to 1 over 1 plus 1, which is equal to 1/2. Okay, so again, we took a limit expression that ended up having an indeterminate form to begin with. We did some trig manipulation. We also did some factoring. So we used 2 methods in this problem. And then we applied direct substitution again. So these problems may take you longer than others. One, because they're a little bit more unfamiliar and they're using things you're not as comfortable using or you haven't used as frequently as other techniques. Again, the overall idea is the same. Can we manipulate the original expression so that when we use substitution, we don't get something that's indeterminate? We get a real number. Okay, let's clear this. You know what? We are going to do number 4 together as well. Then we're going to call it a video, and then we're going to pick up this for part 2. Okay, so before we start this problem, I will tell you that there is going to be another formula that you need to know to be able to evaluate this limit. It is a double angle formula. The reason I didn't put it up above in our list is because it's far less important than the other stuff we wrote down. And there's going to be ways we learn later in calculus that could help you avoid having to use this formula. But at this point, we don't know those techniques, so I'm just going to give you the formula. It doesn't mean you're just going to be able to get the answer right away. There's still going to be some other things you have to do, but I'm going to give it to you because it's not something I would expect you to memorize, and it's not going to be something you would need to know to score or to answer every question on the AP exam, right? There, again, like I said, there's going to be other ways for you to Okay, so before we start this problem, I am going to tell you that there is a formula you're going to need to know to evaluate this limit that we did not put in our list above. And the reason we didn't put it up there is because it's far less important than anything else we wrote down. It's not as important as the Pythagorean identity. It's not as important as the relationships between sine, cosine, tangent, cosecant, secant, and cotangent. And it's not something that you'll ever have to know to solve a question correctly on the AP exam. So there's almost always going to be another technique that you could use. It's one that we haven't learned yet because you don't have the knowledge to use it yet. But later in the course, that will become available and kind of render the use of this formula obsolete. So I'm just going to give it to you because it's not something I would expect you to have memorized. It is the double angle formula. So cosine of 2 theta is going to be equal to 1 minus 2 sine squared of theta. Now, we're not just going to jump right in and use that, but it is going to be something that you want to incorporate in this limit a little bit later. Before we try to manipulate anything, we should always jump to our first step, which is try direct substitution. Okay, see if we get an indeterminate form, or maybe we just get a real number and that's going to be the answer to this limit. So if I evaluate my numerator, and I substitute in negative pi over 4, if we think back to our unit circle, sine of pi over 4 would be square root of 2 over 2, but negative pi over 4 is in the 4th quadrant, which means our sine values are going to be negative. So this is going to give me 1 plus the square root of 2 times negative root 2 over 2. And then if I do some more simplifying, I get 1 minus 2 over 2, which is equal to 0. So our numerator's limit is 0. Now we try our denominator. So it'll be a little bit easier. If I substitute in negative pi over 4, that's going to give me cosine of negative 2 pi over 4, which is equal to cosine of negative pi over 2. And cosine of pi over 2 and cosine of negative pi over 2 are both 0, regardless. So our denominator's limit also goes to 0, and we have an indeterminate form. So we are not done. We are going to have to use either some factoring or some trig manipulation or some rationalizing to be able to figure out this limit. Because I gave you that hint in pink about the double angle formula, we are going to start there. I am going to get rid of what I have in red. I'm not sure which would have been quicker, erasing everything in one click and then rewriting the pink, or erasing the red by hand. But we're done now. So if I start, I'm going to rewrite my limit, of course. I'm going to leave my numerator the same. I'm just going to rewrite my denominator as 1 minus 2 sine squared of theta. Now, just like our previous problem, numerator and denominator look similar, but not quite the same to where we can simplify out any common factors. However, if we take a look at our denominator, it is the difference of two squares. So we could factor our denominator. And if we do that, we should start to see that it's going to look similar to our numerator. Okay, in our denominator, I'm going to get 1 minus the square root of 2 sine of theta times the quantity 1 plus the square root of 2 sine of theta. Now, again, if you're uncomfortable with this factoring, I would encourage you to pause the video, maybe do some extra work on the side, maybe look up how to factor the difference of two squares to really understand what's going on here, because this is something that they're going to expect you to incorporate, and we don't really have time to go back and do a whole review on how to factor. Once we get here, though, we can simplify. So these two simplify, and you know what? I should certainly have my limit here, because they will take points off on the AP exam if you do not carry your limit terminology with you. So down here we will also write our limit. And now it's just the limit of 1 over 1 minus the square root of 2 sine of theta. Now if we use direct substitution, we'll be left with 1 in our numerator. In our denominator, we'll have 1 minus the square root of 2 sine of negative pi over 4. The numerator stays the same, and we get 1 minus the square root of 2. We already know that the sine of pi over 4 is equal to negative root 2 over 2. And let's see, I'm going to come over here because I'm running out of space. And I'm going to get 1 over 1 plus 2 over 2, which is equal to 1 over 2. So our limit here is 1/2. So again, there was still quite a bit of work to do even once you incorporated or implemented the double angle formula. But again, you're going to see patterns amongst these problems that you're working on. You're going to notice, okay, I'm kind of using this factoring technique quite a bit when I'm doing this type of trig problem. So it'll be easier to think of strategies to implement the more problems you do. We are going to stop there for this video. We are going to do the rest of this lesson in the next video. This is Mr. Fawcett. As always, enjoy the rest of your day.